Okay, so this is a family review problem under piecewise functions. So piecewise just means you're putting pieces of the graph together, right? So so in this case, we need to look at, in particular, what these numbers in the parentheses mean. So, and this has to do with the defined part of the function. So, it's like for example, the first is we have two equations here. The first one is 5x minus 3, and the second one is x cubed minus 3. So this is number 9 on your review packet. And but it says here that if you want to use the first equation, you can only use it if it's between -5 and +3. And the second one says you can only use the second equation if it's between 3 and 5. Actually, above 3 and through 5. Okay. So, where do we find out which equation do we use? Well, again, it's going to be what's in the function. So it's saying f of 0. So if it helps you, um, just I would just draw a graph or just draw a line here. And we know for the first one, we can be from -5. And I would do bracket in a bracket. So -5 and +3 for the first one. And then for the second one, it says you can be between the 3 and 5. And so I put a parenthesis on 3 because remember, if it doesn't have an equal sign here, it means it's not included. And the equal sign means the endpoint is included. So since there's no equal sign here, it's not included. But for 5, +5, it is included. So I put a bracket there. Okay. So this is going to be between 3 and 5. Okay. So if I look at my my first point, it wants me to find 0, right? It says f of 0. Well, 0 is going to be between -5 and 3, right? 0 is going to be in here. So that means then I'm going to use the first equation for this one. Okay. So here I'm going to have f of 0, which is going to be 5 times 0 minus 3, which is -3. Okay. Then let's go to the second one. The second one says, okay, now we want f of 1. Well, where is f of 1? 1 is going to be where? Again, between -5 and 3. 1 is going to be probably right here. Okay. So that means I'm going to use again the first equation. Okay, so this is going to be f of 1 equals 5 times 1 minus 3. So 5 times 1 is 5, minus 3 will give us +2. Okay. All right, the third one says, okay, I want, or C in this case, f of 3. So we have to be careful, which 3 are we looking at because there's a 3 here and then there's also a 3 here. Okay. Well, we want the one that says less than or equal to because that means that endpoint, which is 3, is included. This one here does not have the equal sign here, so that means this one is not included. So that means we use the first equation again. Okay. All right, so again, that's why we have the bracket here to tell us that it is included. So we'll have f of 3, and so that would be 5 times 3 minus 3. Okay, so that's going to give us 15 minus 3, which is 12. All right, and then the last one, f of 5, well, 5 is going to be right here. And it is included because we have the less than or equal sign. Okay, so for f of 5, we use the last equation. So f of 5 equals 5 to the third minus 3. And that gives us 122. Okay, and that's how you solve a piecewise defined function. Okay, so this is a log slash exponential equation problem. And what we're trying to do here is we're trying to solve for x. So we want to get x by itself. So how do we do that? Well, we talked about that there are certain steps we have to take to get to that or understand. So, um, So last time we talked about how we can go from a log function to an exponential function and vice versa. And why do we do that? Well, because sometimes if it's written in log, we're not able to solve it. And so what we need to do is we need to change it from a log function to an exponential function. So we learned this little saying of little to the right equals middle. So if you have a log function just like this one, log base 3 of 1/9 equals -2, we can rewrite it from a log function to an exponential. So the base 3 is your little, okay? To the right will be the power, 3 to the -2, and what's in the middle is what's inside the parentheses, okay? So again, so if it's written in log function, like for example, the second one here, we're not able to solve it. However, if we rewrote it to an exponential function, we have b squared equals 4. So that means, b would have to be 2. 2 squared will give me 4. Okay. Same thing for the second one here, or the third one here. Log base 2 of 16. Well, we can try to figure out what x is. Okay. Now, sometimes it's written in exponential function and we don't know how to solve an exponential. So what do? Then we need to change it from the exponential function to a log function. All right. It's just going the opposite direction. All right. So changing it from an exponential type equation to a log function. And that's what's happening here in this problem. Okay. We have an exponential function and we need to change it to a log function because the way it stands right now, we're not able to do it. And some of the problems that we did, um, okay, the leading number or the coefficient of that um, in front of this leading term was 1, okay? And we presented the problem where it wasn't 1, there was a number in front of that. So this one was 4 in front of the E and then 2 in front of the 10. So in order for us to solve it, we needed to divide both sides by that number so we can get that base there by itself. Okay, so that's what we need to do here. All right, so we have 6 times 2. So we want to get the 2 by itself or get rid of that 6 in front of the 2. So we're just going to divide by 6. Okay. So we're going to divide both sides by 6 because again, I have to have the 2 by itself or I can't have any number in front of it. Okay. So 2 to the x plus 3 and is equal to 20 over 6 or 10 over 3. Okay. And then now I can rewrite this from a exponential function to a log function. So this is going to be a log and the base is 2. And then to the right will be x plus 3. And then in the middle will be my 10/3. Okay. So now I can solve this. Okay, so all I need to do now is subtract both sides by 3. And that gives me log of base 2 of 10/3 minus 3 equals x. Okay, so this problem, what it wants us to do is we want to complete a square. Okay, so eventually what we want to do, this is in this quadratic here is written in standard notation. Okay, so this is standard. And we want to write it in vertex notation. So which is f of x equals a times x minus h squared plus k, right? So this is in vertex form. Okay, so that's what we want to do. So your goal is to rewrite it in a way that will have two of the same factors. And in order to do that, we need to use completing the square. Okay, so remember completing a square is using the formula b over 2 square. Okay, now here we have a leading term of 1, which is great. and we can move on and do completing the square. So this will be my first one. The leading term there, or the coefficient of x squared, is 1. The coefficient of x here will be, or in this case, will be my b, and then the last number there will be our c. Okay. All right. So, but before we do that, what we want to do is we want to separate the first two terms from the last term, and they're all going to be on the same equal sign. So I'm not moving anything to the left side of the equation. So I'll have x squared minus 4x, and then I'll have the plus 1 out here. Okay. All right. And then I need to figure out, okay, what do I need to add? All right. So I need to add a box, and then I need to add another box here. Okay. So I need to figure out what do I need to add there? And that's going to come from here, the b over 2 square. So we're going to have a negative 4 divided by 2 square. So that'll be negative 2 square, which is going to give us positive 4. Okay. So that tells me then I'm going to add a positive 4 here. Okay. Use a different color. So I'm going to add a positive 4 there. And then here, because I need to make sure that this side of the equation equals the line above, so I can't add a 4 because that'll give me a plus 8 and a 1, 9. It does not equal to the one above, so I have to subtract that by 4. Okay, so that these guys will cancel, and then this here is the same as above. Okay, because again, this line here, the first line, is the same as this line, so I got to make sure that they are balanced out. Okay, so I add 4 here, and then I'm going to subtract 4. So now we can rewrite this and factor this here. That'll give us x minus 2 times x minus 2. Okay, and then 1 plus positive 4 is going to give us a negative 3. Okay. All right, and this is what we want. We want 2 of the same factors. So that's going to give us x minus 2 squared minus 3. Okay, so that would be f of x equals x minus 2 squared minus 3. Okay, and if I were to graph this, or if it asked me to graph, remember I need to graph my HK, right? So in this case, it's going to go to the right 2 and then down 3. Okay, so this will be 2, negative 3. Okay, and then this is a positive parabola because there's a positive here, so that means this is a happy parabola. And that's it. Okay, so again, this problem here is similar to the previous problem we just did. And the difference here is we do have that 3. So again, how do we address that? All right. So in order to complete the square, all right, that's what we're trying to do. The leading term has to be 1. Okay. The leading term has to be 1. In this case, the leading term is 3. So we can't do it. So what we need to do is we need to find a way so that that leading term is 1. So if we have, again, f of x equals, and then notice what I'm going to do first is I'm going to separate the 3x squared minus 18x and put the 31 like we did last time. So, and then in this case, I'm going to factor out, whatever factor or whatever is in common between the first two terms. So it looks like 3 is a common factor between these two terms. So I'm going to take out a 3, okay? And I'm just going to put this in brackets. Doesn't mean anything, just same thing as parentheses. And then I have x squared minus, and if I pulled out a 3, well, 18 divided by 3 is going to give me 6, or 3 times 6 is going to give me 18. So it's going to be minus 6, okay? All right. then we still got that positive 31 out here. Okay. All right. So that's the key part in solving this is that we need to pull out whatever factor is common between the first two terms. And now we have a situation where we can complete the square now because the leading term is a positive 1. Okay. So we'll have our equation b over 2 squared. And then we also have to be careful because we want to use the one that we're working on, not above it. Okay. So again, we want to use the one that we're currently working on and not above it. So in this case, my b is going to be -6 and not -18. So that'll be -6 divided by 2 raised to the second power, which is -3 squared, which is going to give us a positive 9. So that means I'm going to put a positive 9 here, and then I'm also going to add a box here. So I add a box. Okay, so I put a positive 9, and I also need to add another box out here. But again, like we did before, if I add 9 here, that means I need to subtract this by 9. Okay, if I add 9 here, I need to subtract this by 9. But since we had multiplied or taken out a 3, okay, so again, in order to make sure that this line here is the same as above, then we are not just going to subtract by 9, but we're going to subtract by the um, the number that's being multiplied to this trinomial here, right? So we have a factor of 3. So it'll be 3 times 9, which is equal to 27. So we're not going to add 9 here or subtract 9 here, but we're going to subtract 27. Okay, because our number has changed because we pulled out that 3. Okay. All right, so now what we need to do is we need to simplify this. So we have 3, okay, and then we have x squared minus 6x plus 9, so I can factor that, and that's going to give us x minus 3 times x minus 3. And then 31 plus -27 is going to give us a positive 4. Again, my goal is to write this in vertex form, and and I'm getting close to it. Okay, so we got the two factors that we need. Okay, all right. And we have our coefficient here and then a number out here. So if I were to rewrite this, I'll have 3 times x minus squared to the second power, okay, or x minus 3 to the second power plus 4. So this is going to be our f of x. Okay. Again, if we were to graph this, I'm going to go to the right 3 and then up 4. Okay, and then again, we still have a positive here, so that means we're going to have a happy parabola. Okay, so it says to determine the quadratic function f whose graph is given. The vertex is -3, -12, and the y-intercept is -3. So remember, the vertex is the lowest or the highest point on the graph, right? So this is -3, -12, which is right here. So that's the lowest point. Okay, and so this is representing our HK, our vertex. And then we have a y-intercept -3. And so this is going to represent the coordinate x, y. All right. So why did I write that down? Well, we need to use the vertex form to figure this out. So the vertex form again is f of x, excuse me, is equal to a times x minus h squared plus k. Okay, and then our goal here is to solve for a or find a. Okay, so f of x, we can rewrite that as y, right? So in this case, we already know our y and x values kind of come from 0, 3 from our intercept. So we're going to have -3 is equal to a, again, looking for a, and then x is going to be 0, and then minus h will give us -3, okay? And then we have a plus k, which is a -12. All right, so we have a, and then two negatives can give us a positive, so it'll be a +3 minus 12. Okay, and then we're going to add 12 to both sides. So that gives us a +9. And then a times 3 is just 3a, and then divide both sides by, hold on for a second. Did I mess up somewhere? Oh, I forgot the square. Okay, there's a square there. So this should be 3 square, which is going to give us 9a, not 3a. Okay. So this should be 9. Okay, so we divide by 9. There we go. Let me erase that there. Okay. So 0, negative is a +3, square it, right? So we get 3 squared, which is gonna give us 9a. Then we're gonna add 12 to both sides, all right? And that's gonna give us a +9 on the left, and then we'll have 9a left over, and then divide both sides by 9. So a is going to give us 1. Okay. And that's what we want, because again, we're looking for a. So we're going to rewrite this now in vertex form. So we have f of x equals, and we know what a is, it's 1. And then we have x minus h, right? So that's going to give us a +3 square, and then the -12 here. Okay. Because again, the equation is right here. Okay. All right. If asks us to, okay, now if it asks us to go from vertex to standard, then, we just multiply this out and simplify. So this would be, x plus 3 times x plus 3 minus 12. All right, and then this will give me, if I multiply this together, I'll get square the front, multiply the 2, so double it, plus 9. Okay, so if I multiply x plus 3 times x plus 3, we'll get x squared plus 6x plus 9 minus 12. So we'll get x squared plus 6x minus 3. Okay, so this will be your standard form. Okay, so this one says find a function that is finally graphed after the following transformation are applied. Okay, so basically we're not, it's kind of confusing, but we're not graphing anything. What should ask is find the function that's finally um like what's the final equation? That's what we're looking for.
I actually meant the first section, sorry.
Say again. Oh, the first section?
Yeah, the first section.
Okay.
I mixed it up.
Okay, let me just finish this real quick then. So in this case, you know, I'm going to start with y equals f square root of x, or in this case, f of x is equal to square root of x. Okay. And then I want to shift up 7 units, so that's going to be square root of x plus 7. Okay. And then I'm going to keep whatever I had on the first step, And the next step says I want to reflect about the x-axis. So that means we're just going to put a negative in front of that whole function. Okay. All right. So that will be, so again, this is the first one. Here's the second one. And the third one says we want to reflect about the y-axis. So part 3, that's going to be negative. And then to reflect about the y-axis, we have to put a negative inside whatever variable that we have. So in this case, we're going to put a negative x inside that radical. Excuse me, then plus 7. Okay. And then that will be our final equation there. Okay, so this next one, it wants us to find 3 things, if possible. So this is a rational function. That means rational just means a fancy way of fraction form, right? This means in fraction form. All right. So we want to find the vertical, horizontal, and oblique asymptote. So to find the vertical asymptote, all we need to do, so again, to find VA, vertical asymptote, we just take the denominator, all right, and then we equal it to 0. Okay, because we're trying to see if there's any numbers in the denominator which makes this undefined. Okay, so that's what we're uh, doing here. So if we were to factor this, we would get x minus 7 times x plus 2, which is equal to 0. Then we set both of them equal to 0. So this is going to give us x equals 7, x equals negative 2. All right, so what does that mean? Well, that means that these are going to be our vertical asymptotes. Okay. All right, so now we need to find our horizontal or oblique asymptotes, again, if we have any. So in order to find those, we need to use the chart in our formula sheet. Okay, so we have this chart here. All right, and it tells us, we need to focus on the power or the exponent of the leading term for the top and the bottom. Okay, so we need to identify, which one we're going to be using. And so let's go back to that problem. So here we have a power of x to the 1, and we have a power of 2. So n is less than m, right? Or 1 is less than 2. So we need to find where this is the case. So it looks like it's the first one, n is less than m. So if n is less than m, then it says we would have a horizontal asymptote at y equals 0. Okay, and that's it. So that's what we need to write down. Okay, so since n is less than m, then that means we have a horizontal asymptote at y is equal to 0. And that's it. Okay. All right, so this problem is asking for the intercepts, right? So in order to find the x-intercept, we set y is equal to 0, and in order to find the y-intercept, we set x equals 0, right? So in this case, we have x squared plus 8x minus 20, so we're just going to set that equal to 0 to find the y-intercept. So to find the x-intercept. Okay. So in this case, we're going to factor this, so we get x plus 10 times that by x minus 2 equals 0. Set them both equal to 0. So x gives us negative 10 and positive 2. So that's our x-intercepts. And then for the y-intercept, anytime we see an x, we set it equal to 0. Okay? So we'll have x squared plus 8x minus 20 equals 0. Sorry, not equal to 0. Anytime we see an x, we just replace it by 0. So 0 squared times 8 times 0 minus 20. So y is equal to negative 20. So that would be our y-intercept. Okay, so we're going to use the vertex form again for this problem. And our goal again is to solve for A. Okay. So we have f of x is equal to a times x minus h squared plus k. All right. And so they tell us that the vertex is 1, negative 1. So that's our hk. And then we have given the point 37. So that's going to be our xy. Okay. And then we plug everything in. So remember, f of x is the same thing as y. So I have 7 equals a times x, which is 3, minus h, which is 1 squared, plus k is negative 1. Okay, and then we just solve for a. So we'll have 7 is equal to a times 3 minus 1 is 2 squared plus negative 1, or just minus 1. So we have 2 squared, which gives us 4. So it's going to be a times 4 minus 1 equals 7. And then a times 4 is just 4a minus 1. Then we add 1 to both sides. We get 8 is equal to 4a. And then we divide both sides by 4. Okay, so 8 divided by 4 is 2. So there's our a right there, and that's what we want. And then we just plug everything back in to this equation. Okay, so we have f of x is equal to a, which is 2 times x minus, our h was 1 square, and then our k was negative 1. And then that's our answer there. It did say we want to answer the form in standard form, so we just multiply this out. So again, if it's in vertex form, we leave it the way it is. If it's standard form, then we don't want the parentheses. So that's just going to be 2 times the x minus 1 square is going to be x squared minus 2x plus 1. And then minus 1. Distribute that 2 gives us 2x squared minus 4x plus 2 minus 1. And then we'll have 2x squared minus 4x. Plus 2 minus 1 is going to give us a plus 1. All right, and then there is our answer here. So again, this will be our standard, and this will be our vertex form. Okay, so this problem, we want to find the maximum or minimum value. So in order to find the maximum or the minimum value, we need to formula x is equal to negative b over 2a. Okay. All right. So in this case, remember our standard form is f of x is equal to ax squared plus bx plus c. So here, all we have is an a and the b. So here's our a and here's our b. There is no c. Okay. But we don't need that because all we need is the b and the a. Okay. All right. So if we use this formula here, we have our b is going to be 12, so I'll put a minus 12 here. And then 2 times a is 6, so 2 times 6. So negative 12 divided by 12 will give us a negative 1. And then I just plug in. So this is our x, okay? And so I just plug in negative 1 in there. So we get 6 times negative 1 squared plus 12 times negative 1. So I put that in a calculator. That gives me 6 minus 12, which is negative 6. Okay. So we have the coordinate of negative 1, negative 6. So we go back to our equation here. And we need to figure out, okay, do we have a maximum or minimum value? Well, the 6 here tells us we have a positive leading term. So that means we have a happy parabola. Okay. So that means in this case, we have a minimum, okay, at this particular point, negative 1, negative 6. Okay. Okay, so here we have, this is the price P and the quantity X sold of a certain product obey the demand equation. P equals negative 16X plus 60. We're going from 0 to 360. Express the revenue as a function of X. All right, so that one, remember, this has to be a quadratic, right? Because we're trying to maximize the revenue. So we need a quadratic equation. So here we need R of X, okay? And it's going to be X times P. So that'll be X times, we know what P is, right? So again, this is the general form, X times P. And so we know P is right here. So we just multiply those guys together, negative 16X plus 60. So that gives me negative X squared over 6 plus 60X. Okay. Or I'm going to rewrite that as negative 16X squared plus 60X. Okay. All right. And then now what I want is, so anyway, so that's part A, right? It says we want to express, the revenue R as a function of X. So here's R of X, and this is in terms of X. That's what it's saying. So we have the variable in terms of X. So we're done with that part. All right, so now part B. Part B says, okay, what is the revenue if 66 units are sold? Well, we're just going to plug in our value. Okay, so for part B, so again, this is A. So for part B, we're going to plug in 66. So negative 66 square plus 60 times 66. Okay. So that gives us $3,234. So that means if they sold 66 units, okay, they would make this much money. Okay. All right. Part C. It says what quantity X maximize the revenue. All right. So anytime it's dealing with maximizing, we use the formula X is equal to negative B over 2A, just like we did before. And then we just go here and then label this. So this will be our A, and then that will be our B. So this will be a negative 60 divided by 2 times negative 16. Okay. So that's going to give us 180. All right. So there's our X is 180. So what quantity X maxes the revenue? 180. Okay, and then it says the second part, what is the maximum revenue? Well, we just plug in 180 in for, again, our R of X. So this is C, continue. So R times 1 of 180 is equal to negative 16 times 180 squared plus 60 times 180. Okay. All right, when we do that, we get $5,400. Okay, so there's our answer for part C. There's the answer for part B. Okay, and then the last one here, part D. What price should the company charge to maximize the revenue? Well, we do have the price, right? The price P is this equation here. So we just plug in, we found out what X needed to be, right, to maximize the revenue. Now we just need to figure out what the price should be. Well, we already have a price equation. So it's P is equal to negative 16X plus 60. So we just plug in X, 180 for X. So negative 16 times 180 plus 160. Okay. And oh, I'm sorry, not 160, just 60 there. Erase that part. Okay, so negative 16 times 180 plus 60, that's going to give us $30. Okay, so this is, oh shoot. Okay, so this one is asking us to determine the maximum and minimum value or minimum value. So we have a, oops. So here's our quadratic, right? 2x squared plus 12x minus 9. So again, in order to find the maximum or minimum value, you use the equation x equals negative b over 2a. Okay. So, and then we just identify which our A, B, and C are. So here's our A, here's our B, and here's our C. And then we plug in our value. So our B in this case is going to be 12. So that'll be a minus 12. And then 2 times A, which is 2. So 2 times 2. So negative 12 divided by 4, which gives us a negative 3. Okay. And then once we find x, then we just plug it in for our function here. So it'll be f of negative 3. And we'll have 2 times negative 3 squared plus 12 times negative 3 minus 9. Okay. When we simplify this, we will get negative 27. All right. So we have the coordinate negative 3, negative 27. And so we have to determine whether this is a maximum or a minimum. Well, we look at our leading term here, which is positive, right? It's a positive 2, so that means we have a happy parabola. So that means then we have a minimum at negative 3, negative 27.